Hi guys, my name is Andrea Sava and today I will be discussing the experiment of the elephant toothpaste. The materials that we will be using today, it's active dry yeast, regular dish soap, some food coloring, an empty water bottle, and 3% hydrogen peroxide. The chemical reaction of this experiment is when hydrogen peroxide reacts with yeast, which is a catalyst, it makes water and oxygen. 200 peroxide react with yeast. It makes two waters and oxygen as gas. What is a catalyst? So a catalyst is a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. When a hydrogen peroxide breaks down, it turns into oxygen and water. Normally, this breakdown happens very slowly, but the reaction could be done faster by adding a catalyst, where it speeds up the chemical decomposition reaction of the hydrogen peroxide, but it remains yeast, so does not chemically change itself. The hydrogen peroxide decomposes to form oxygen as gas, as we said, and water. Yeast is an organism that contains a special chemical called catalase that can act as a catalyst to help break down hydrogen peroxide. Catalase is present in almost all living things that are exposed to oxygen, and it helps it helps them break down naturally occurring hydrogen peroxide. Hydrogen peroxide can be produced by plants and animals. This reaction is called an exothermic reaction. What is an exothermic reaction? An exothermic reaction is a chemical reaction in which less energy is needed to break bonds in the reactants that is released when new bonds form in the products. During an exothermic reaction, energy is constantly given off, often in the form of heat. All combustion reactions are exothermic reactions. An exothermic process releases heat, causing the temperature of the immediate surroundings to rise. Combustion or burning is a high temperature exothermic redox chemical reaction between a fuel and an oxidant, usually atmospheric oxygen, that produces oxidized, often gaseous products in a mixture termed as smoke. So in this experiment, I tried to make two experiments. So the first experiment, I put less hydrogen peroxide, and as I said, I used 3% hydrogen peroxide, while the uh, experiment was requesting for a 10% hydrogen peroxide, which is more active, but I couldn't get that from a regular pharmacy. So I used a 3% hydrogen peroxide. I put less concentration of hydrogen peroxide, and I put the same amount of liquid soap in both experiments, and food coloring and yeast for the two experiments. So as we can see here, this is the first video. So I already have in the bottle the food coloring, the dish soap, and the hydrogen peroxide. I use a little hot water in order to dissolve the dry yeast in the measuring cup. Um, and this is the experiment. So as you can see in the measuring cup, the water is on top and the yeast is on the bottom. So maybe I didn't dissolve the yeast that much, and also the concentration plays an important role in the reaction of this experiment. We can see the bubbles that are forming, which is oxygen basically. As we said earlier, hydrogen peroxide with yeast reacts in order to produce water and oxygen. We can see the bubbles, but the reaction is not that effective. So I waited a few seconds. I tried to shake the bottle a little bit. Nothing happened. All right, concentration affects the rate of the reaction, as we said earlier. So how does concentration affect the reaction time of hydrogen peroxide? So once you add more hydrogen peroxide to the solution, the reaction rate will increase as more substrate molecules can collide with the enzyme, forming more product. The result is an increasing amount of foam produced in your cup as you increase the amount of hydrogen peroxide in your reaction. So when I increase the amount of the hydrogen peroxide in the reaction, we see the bottle is almost filled. Uh, we see something interesting happening. I also make sure that this time I was completely dissolving the active dry yeast in the water. You can see now the reaction is more reactive. See now, and this is the elephant toothpaste experiment. All right, so if you mix, as we said, yeast with hydrogen peroxide, the hydrogen peroxide will rapidly break down into water and oxygen gas. The oxygen gas form bubbles. These bubbles would usually escape from the liquid and pop quickly, but adding a little dish soap provides additional surface tension, allowing the bubbles to get trapped and creating a lots of foam. These foam look like a giant squeeze toothpaste. That's why this is called elephant toothpaste. Thank you.